Hey CW Apes, Mr. Kennedy here with part 2 of your soil notes. In the first video, you got to learn all about soil texture, how soil is formed. We dug really deep to make sure that we got all that stuff covered in great detail. Now we're going to take a look at problems, basically the ways we use and abuse our soil and some possible fixes to wrap this chapter up. So just to kind of start us off, the way we abuse and use our soil begins with agriculture. Approximately 12.5% of the Earth's land area is currently in agricultural production, with a potential of up to 4 times as much more to be used. So there's a couple of things that I always think about when I hear numbers like that. One thing I think about is, well, our population is continuing to get bigger and bigger, and we're putting more and more strain on agriculture to feed all of the people of the world. So why are we only using 12.5% of, the Earth's land mass to grow food? Well, that other 4 times area, while it does show potential for agricultural use, realistically, well, to turn it into agricultural land might be more trouble than it's really worth. Maybe the land is like steeply sloped or has soggy, less than desirable soil. Maybe it's too cold there. The growing season isn't long enough, or it doesn't rain enough. There's not enough water, so you got to pump it out of the ground. Or maybe there's just salt in the soil. Like, those are things that we could fix to potentially grow food there, but you have to weigh the cost and whether or not it's going to be worth your while. The other thing that I think about is if we have 12% of the Earth's surface, land area, that's being used for agricultural use and our population keeps getting bigger, well, that means that we're going to put more and more and more stress and strain on that 12% so that we can feed all the people of the world. So that's something that, I want you to think about as we talk about soil problems, because at the outset, without soil, as FDR said, we're going to destroy ourselves. So let's get into this idea of arable land. Okay, arable land is land that could be used for agricultural use. Aside from the fact that 12% of the Earth's landmass is being used for that, or is arable, that land is also not evenly distributed across the surface of the Earth. In North America and Europe, we're actually pretty lucky that we have huge expanses of what was once grassland that we can use to grow food. There are many countries across the globe that lack suitable soil for this. I mean, as crazy as it sounds, you can't grow crops like we do here in the United States. Someplace like, Brazil, they've got rainforest all over the place, for Pete's sakes. It rains over 200 centimeters a year. Like, if you tried to grow crops like we have here, like wheat and stuff like that in Brazil, it would just rot, okay? So that's not okay. So how do countries that live in places without arable land feed their people? They've got to import it, okay? Gains in agricultural production have come from increased fertilization, fertilizer use, pesticides, irrigation, stuff like that to help some of these countries out. But there are other places where there's just not a lot we can do, okay? As productivity, even in North America and Europe, has increased in recent years, some marginal lands have been retired and less land is now cultivated than in the past because there's just not a lot we can do. Excess wind, water, erosion, these are all things that, create problems for us here in the United States as well as other countries. Wind and water erosion ruin farmland by taking away the topsoil, the organic matter that the agricultural plants need in order to survive. Without that topsoil, the farmer has no choice but to use fertilizers. Oftentimes, it's cheap and easy to use chemical fertilizers that are kind of like giving your plants a candy bar. The plant will grow fast, but that fertilizer doesn't last very long, and you're irrigating or it rains, a lot of times that fertilizer gets washed off into the waterways and creates other problems. Soil losses do cut farm production. I mean, it's simple. If you don't have good soil, then you're not going to, produce bumper crops of food or whatever it is you're growing. Okay, cotton, who knows? Every year, about 3 million hectares of cropland worldwide are made unusable by just erosion alone, and another 4 million hectares are converted to non-agricultural use. So you remember that 12% that I said we had? Well, that's where I say we're putting more and more and more stress and strain on what land we still have available. Most land degradation happens slowly as soil washes or blows away. Sometimes it's salt accumulation from poor irrigation practices, and maybe just heavy feeding crops pull all the organic matter out. As a consequence of the process, as well as increases in world population, arable lands worldwide have shrunk from 3.38 hectares per person in 1970 to as little as 0.23 hectares per person in the year 2000. So that just tells you we have less and less and less farmland to feed more and more people. Okay? Now, getting back to this erosion thing, wind blows across the surface, water, cuts through the surface of soil, and it takes the dirt with it. A farm can lose up to 20 metric tons of soil, per hectare per year from one of these processes alone. You start multiplying them, and that number goes up. There's different types of erosion that I want you to be familiar with, so I've listed them for you here. I'll show you some pictures of them as we go along. There is sheet erosion, and in sheet erosion, a thin layer of surface will simply be like washed off by water as it courses by. Real erosion, this is where we get small rivulets, you kind of look like cracks or crevices in the surface, where water finds kind of like a weak spot in the soil and slowly starts to cut in. Then there's gully erosion. This is like, almost like making a big ditch, and you get a channel where the water flows through that. Along streams and rivers, you get what's called stream bank erosion, and that's something, maybe you've seen it, maybe you haven't. Kind of the fun place to see it is at the beach. Sometimes the rivers from the surrounding area will actually go out to the ocean, and you'll see like water, cutting through the sand, and as it cuts through the sand, like chunks of the stream bank will like fall off into the water, and it's kind of fun to play with. Okay, so this is just some examples of the different types of erosion. So this first picture really, I think, is indicative of sheet erosion, where you have like a broad expanse of water that like covers across the surface and takes soil with it. And then you've got like gully and or like, stream bank erosion that can be like pictured here. So this is where you kind of get like a big ditch, and if water's pouring through here, then like chunks will fall off the side. Okay, another way to imagine this is this probably started off as real erosion, which you just had like a little crack or crevice, and then it just got worse and worse and worse over time. Okay, wind can also move soil. Wind can equal or exceed water as an erosive force, especially in dry climates and on flat land. I've got some other pictures to show you like the amazing things that wind can do when we look at like the Dust Bowl that occurred in the United States several decades ago. Desertification is the end result often of wind erosion, where basically we convert productive land into a desert. And all that is usually started with intensive farming practices that lead to erosion, and it sort of dominoes into this desertification effect, and then no one can use the land. So to give you some ideas of intensive farming practices that might lead to desertification, well, you have row crops that are, leave your soil exposed. You have weed-free fields, which you might look at that and go, well, why is that bad? Well, if you just have dirt, just bare dirt exposed to the wind and rain, well, when winds blow across that, it takes the dirt with it. If there's, if you're not going to plant crops in this field, at least let the weeds grow so that holds the dirt in place. Removal of windbreaks. I used to, when I was a kid, I'd drive around, the outskirts of town, and I used to wonder why, you'd just come across on a country road this random like bunch of trees just standing in rows like that. And I'm like, what is up with that? Well, it's a wind break. That's why it's there. So when the winds are blowing through, it'll hit the trees and disperse the wind and hopefully reduce the damage that it can do. No crop rotation or resting periods in fields can also lead to desertification, and continued monoculture cropping can increase soil loss. So these are all intensive, farming practices that clearly are bad for our soil. Now let's go through and kind of look at some, better pictures of this so we can visualize this and have it sink in. So I've got protected soil and unprotected soil for you here, just to kind of compare what's going to happen when it gets wet or wind blows, and how erosion plays into all of this. So if we have soil with any kind of vegetation on top of it, okay, doesn't matter if it's raining, if the water pools up and then runs, if the wind is blowing, you could see that the soil pretty much stays intact. The plant root and the plant above ground, diffuses any wind or water damage, and the soil, remains. If the soil is unprotected, well, that same amount of rainwater that was no big deal for the protected soil is going to start to form rivulets or cut into the weak spots that it can find, or low spots that it can find in the soil, and start to flow and take dirt with it as it does so. Wind can come right across the top and scour that soil away, and at the end of the day, that unprotected soil will probably lose all of its organic matter. The O horizon will be gone, the A horizon will be heavily depleted, and it'll be really hard to grow plants, to grow agricultural plants in that at any time. Now, this will give you a little bit different look at erosion. So I know a lot of people that like to go four-wheeling, and unfortunately, four-wheeling kind of gets a bad name when it comes to erosion. This is why. So you take these cars, you drive them up and down these hills, and basically destroy any plant material that's holding the soil in place. Then when it rains or when winds kick up, if you look closely at this picture, you can start to see little cuts that are forming here in the hillside. Those cuts are real erosion. So those are those little rivulets that form as water finds a weak spot and starts to cut away into the soil. This whole area here where you've got this big indentation is more indicative of gully erosion. And, there's no stream erosion here because there's no stream, but, the four-wheel driving and all that kind of stuff just kind of add to the problem. Okay, so plants, at the end of the day, are really important to anchor the soil and prevent erosion. If we go to satellite imagery, we can see just how serious erosion can be on a large scale. So this is all along the coastline, Gulf of Mexico here in the United States, where like the Mississippi drains into the Gulf of Mexico. And you could see that, rivers like the Mississippi can actually dump literally tons of soil out into the Gulf. Human activities upstream, like logging and farming and just, animal grazing, can destroy the plant coverage. Then when it rains, all that stuff ends up in the rivers and then flows out to sea. Now, it is often argued, Mr. Kennedy, like it's important to get minerals to flow downstream. So, downstream we can have a replenishment of organic material from what's going on upstream. And I would agree, it's important in the natural ebb and flow of the life cycle of the river or the life cycle of the ocean that, you need to get water to travel down these streams out to sea. And it's okay if some mineral content goes with it. The problem is the volume you're seeing here. That's the problem. Not that it's happening at all. It's just that it's happening at such a large scale that it ultimately chokes out more life than it helps. Okay. So here's again some more pictures to help you visualize the different types of erosion. Sheet erosion up here in the corner where you've got water going over a broad expanse. Rill erosion. This is a much better picture than the last one I showed you. This is gully erosion. So you kind of have a ditch and then stream bank erosion. These cows aren't helping much; they're kind of in the way. But as the stream, flows, then the material like falls in. Okay, here's another example of erosion that I want you to just sort of soak in. This is UCSB at Isla Vista. These houses are literally built right on the cliff edge. And as the ocean comes in, sea waves will eventually undercut the cliff, and these homes will probably fall into the sea in due time. Okay, so you can see here that people have done their best to kind of support the house. They're putting in concrete footing. They're putting in like little barricades down here to help diffuse the ocean waves. But the inevitable is the inevitable. And the moral of the story is, if you don't want your house to fall into the ocean, don't build it right there on the edge of a cliff. Okay, because as the wave action continues, it's gonna take that down. This is the American Dust Bowl. So the American Dust Bowl, this is a dust storm outside of Barstow, California. This is the actual dust bowl that happened in the northern stretches of Texas, Oklahoma, Kansas, Colorado, and even a little bit over into New Mexico. This is the book or the story that the book Grapes of Wrath is based on. When you're looking at this kind of dust storm outside of Barstow, or this dust bowl that occurred several decades ago in Texas and Kansas and Colorado, you have to ask yourself, why? Why did this happen? Well, it's really simple. Farmers, as it says here, removed native plants and were basically using the landscape for agriculture. The native plants anchored soil year-round, whereas the agricultural crops that they had planted were annual. To make a long story short, the Dust Bowl happened at the end of a drought. So they had been experiencing a drought back in the early 1900s here when this occurred. And the crops failed, left field after field, acre after acre of exposed dry soil, and then the wind picked up, and the rest is history. Okay, so the wind picked up, and we had just insane dust storms that literally buried farms. Okay, as topsoil was blown away, it completely destroyed whole families and communities' livelihoods, as this dirt basically just blew right across the heartland of America. Okay, now this idea of soil degradation is not something that is unique to the U.S. You can see from this map there are plenty of areas of serious concern around the globe, because we're not the only ones that may not be using our soil well. This is desertification. Remember, arable land is farmable land, and basically, because of climate change and the way humans are treating the soil, we're seeing a decrease in this arable land globally. Great losses are occurring in nutrient-poor soils of Africa and India, where 1 billion people depend on what is already nutrient-poor soil for their survival. Number one causes, again, it's all people stuff. Like we're overgrazing our rangelands, we're deforesting, surface mining without replication is creating problems. We're farming low quality land as it is, and basically those crops are leaving huge expanses of area exposed to erosion. And just being out there on the soil compacts the soil and reduces its ability to support plant life. Here's some maps to kind of give you an idea where desertification is spreading and where it is most severe. You can see if you look real close to the map, this is us over here in California, and yeah, we're having problems with it here. Okay. Desertification of productive lands literally threatens 1/3 of the Earth's surface, and again, over 1 billion people. All right. Africa and China are of particular concern, but that doesn't rule out the United States. Rapid population growth and poverty create unsustainable pressures in places like Africa and China. The removal of trees for fodder and firewood triggers climate change and accelerates the desertification process in these countries. Okay, just kind of give you an idea of how that plays out. Here's a graphic that we can use to not only talk about desertification, but even salinization and waterlogging in our soils. So in terms of desertification, right, if we overgraze this soil, all this plant material will be lost. When that plant material is lost, that's going to decrease what's called evapotranspiration and dry out the air above the soil. You dry out the air above the soil, and that means less rain. Less rain means that you've got more winds, more dry air, and the topsoil is washed away by erosion from wind, and that's desertification. Now, a couple of other things that are on this slide that I also want to mention is salinization and waterlogging. So sometimes we can take marginal land where maybe it doesn't rain enough and, try to, grow our crops there. But that's going to require irrigation. Well, depending upon the soil type that you have and how closely you monitor your irrigation, you can actually waterlog your crop. Waterlogging means that the subsoils basically don't drain the water like they're supposed to. The water just sits right below the plants in their root system and causes the roots to decay, killing all of the plants. In California, we have a lovely substance that in some places is maybe just a few inches underground called hardpan. Hardpan will not drain water. So if you water, the ground above hardpan heavily, then the water's just going to percolate down to the hardpan and sit there. I can speak from personal experience. I was having a pool installed in the middle of summer. I did not water my backyard for like 2 weeks. It was over 100 degrees. I thought it was bone dry. They bring in the tractor and they start running back and forth through my yard. And next thing I know, I've got a mud pit. I'm like, where'd all that water come from? Well, about 3 feet underground, there was a layer of hardpan. And because all my neighbors kept watering their lawns and things, the water moved across the hardpan and just sort of settled in. Okay. So that's what waterlogging is all about. And it's just as deadly to plants as no water at all. One other thing to consider in this slide is what's called salinization. When the subsoils are wet and the plants above it or even just the air above it draw the water up, that can bring minerals out of the soil to the surface, and those minerals can deposit salts on the surface that again are toxic to life. So proper irrigation practices and using, marginal lands, both of those things can, be serious issues that we've got to deal with to maintain healthy soils for the years to come. So how do we fix things? Well, here's some solutions. We have the Soil Erosion Act of 1935, which was designed to give technical assistance to farmers. In 1985, we passed the Farm Act, which create reserves to give farmers a subsidy for not farming and planting soil-saving grasses or trees for 10 years. Okay. Requires 5-year soil conservation plans, and it even forgives debts for not farming highly erodible croplands or wetlands and restoring them. There are lots of other things that we can do. Soil conservation and regeneration really just involves maybe some simple tweaks that can help in the long term. We can do conservation tillage and crop rotation. Conservation tillage, well, basically that means we take last year's crop residue, we mix that back into the soil. It will decompose and increase our water holding capacity and nutrient content. Crop rotation means that we're going to alternate heavy feeding crops for crops that actually put stuff back in the soil in alternating years. We can even do things like contour plowing. Contour plowing is pictured here on the right side of the screen, where we plow against the slope to reduce runoff. We can do strip farming, where we plant different crops in rows and harvest at different times. That's the next picture down. We can terrace. Terracing creates shelves on steep slopes, again, to reduce erosion. We can do alley cropping, where trees and crops are planted in alleyways, utilizing the space that's available to us and covering exposed soil. And we can plant windbreaks. I mentioned those a while ago to reduce wind erosion. So these are all things that are positives. These are all things that we can do to help our soil. All right, ladies and gents, that's how we use and abuse our soil and some things that we can do to keep it safe and sustained for generations to come. I hope you've learned lots about dirt. I'm Mr. Kennedy, and I will see you next time.